Hi there, in this video I'm going to machine the intake and exhaust units, and the intake unit will eventually house the carburettor jet. Now the exhaust unit has got a valve seat that's quite way inside, and sort of looking at the instructions they basically just say, oh, use a small boring bar to cut it, but I just think that's impossible. And I know Earl's had a problem with that approach, and he ended up making a special tool. So having pondered it over a while, for a couple of days, I've decided to have a go at modifying the design, so hence the computer. So let's see how we get on. So I've put the drawings into Fusion 360, and this is a drawing of the exhaust valve body. Now I haven't included the exhaust valve seat in here. Instead of including it, I've drilled a hole right through the body, which will take the valve cage, which I'll make separately. So this is a drawing of the exhaust valve cage made out of phosphor bronze, which I'll make separately. Now the valve seat on this is quite wide, and in reality it's probably going to be less than that. Okay, so this is the completed exhaust valve assembly. So this is the body incorporating the valve cage that's been pressed into the base of it. And as you can see, the valve seat is quite sort of low in there, so how you can machine that as a complete unit, I don't know. And as part of the machining process, I'll bore a hole through into the valve cage at that point. So this is the intake valve body, and it's a far simpler design than the exhaust valve body. So this is the intake valve cage, again made out of phosphor bronze. The seat on this is probably wider than it would be in reality. Dimensions are very similar to the exhaust valve cage. So this is the intake valve assembly, and as you can see the cage has been pressed into the body. Far simpler assembly, and you can see the hole needs to be bored into the cage as part of the machining process, and the valve seat on this again is probably too wide, and it'll be sort of thinner than that in reality. So that's the plan, so let's see how we get on machining it. Well, these drawings should have come out on a scale of 2:1, but the printer refused to do that, so I think they're on a scale of about 1.5 to 1. Anyway, never mind. So first of all, I'm going to start on the exhaust valve body, and I'm going to machine this boss here first of all. So I'll put it in the 4-jaw chuck on the lathe. Well, it's taken me ages centering this up in the 4-jaw chuck, but got there in the end, I think. Okay, so the outside diameter of this boss needs to be 7/16 of an inch, so if I divide that by 2 I'll get 7/32. Now I've put the tool tip just short of the centre mark, and what I'm going to do now is I'm going to draw the cross slide by 7/32 of an inch, which is 0.218. One, 2, 1, 8. So if I set that to 0 now, I know exactly where I need to cut up to, and it'll be just shy of 7/16. So it'll be just be a bit bigger than that, but I can then use the cutting tool just to clean it up. So I've just rotated the piece by hand and just scratched the mark with the tool, and that is just slightly greater than 7/16. So I'm happy to proceed. And I've set the carriage stop to 1/4 inch in. Now this will eventually be tapped to 5/16 B26, but what I'll do while it's on the lathe is I'll just drill a pilot hole around about 6mm in diameter, but I'll do all that off camera. Okay, so now I need to go over to the mill and drill and ream the hole to take the valve cage, so that will have an outside diameter of 7/16 of an inch there. At the same time, on the mill, I'll drill these holes through here to secure it to the cylinder block, and they need to be number 32 UNC 4x40 UNC clear. And what else am I going to do? Oh yeah, I'm going to drill this hole here in the back. So this is the hole for the valve cage, and I've already centre drilled. So I can't do much more on this until I insert the valve cage. And now onto the intake valve body. So a lot of this is just drilling holes in the right place. So this is 4x40 UNC clear. Well, it seems to be going to plan. So the idea is that the inlet valve cage will fit in here. And once it's fitted, I can then drill through this hole into it. And the inlet valve cage will protrude very slightly so that it will fit into this recess here. And then I can bolt it together. And for the exhaust valve cage that will fit in there. Once that's fitted, I can then drill through this hole here into the valve cage. So that's the plan. So I need to make some valve cages and valves. Okay, so for the valve cages I'm going to hold a piece of phosphor bronze in a collet chuck at this end, and I'll first of all open up this hole here, then I'll drill and ream this hole to be 1/8 of an inch. Once I've done that, I'll then turn the outside diameter down to be around about 1/2 thou over the actual hole I made here. So I'm going to get a really good interference fit, hopefully. Once I've done that, I'll then cut the valve seat at 45 degrees. Then I can part it off, then I can switch it round and then just turn this end down here. Okay, so before undertaking any machining, I decided to turn the compound slide round to 45 degrees, and to make sure I got an exact 45 degree angle, I used the following method. I moved the tool up to this edge of this phosphor bronze, and then I withdrew the compound slide by 11mm. Now, it could be anything really, but I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if I take the sine of 45, that's 0.7071, and 11mm equates to 0.433 of an inch. So if I multiply the sine of 45 by 0.433, I get 0.306. So the gap here has got to be 0.306. So all I did was to put my slip gauges in here to make sure, to measure that gap. And after a bit of fiddling around, I've managed to get that gap to be spot on 0.306. So I'm happy the compound slide is set to 45 degrees. And another way to measure that gap is to use a gauge. So I've already centre drilled, so what I need to do is open this up now to 9/32 of an inch in diameter to a length of 7/16. So what I need to do now is to drill and ream the top end to 1/8 of an inch in diameter. So this is a 3mm drill bit. So I'll drill to a length of 1/2 an inch, and later on I'll ream it off camera because it's a hand reamer. Oops. Let's try again. So this needs to be reduced to 1/2 thou over the size of that. Well, that just slips on there on the end, and the difference between the end and the main bit is 1.2 of a thou. So I think that'll be a good tight fit, an interference fit. So I'll leave it at that. So now I need to cut this valve seat. So now I need to reduce this to 1/4 of an inch in diameter. Well, that seemed to work out okay. And now the only slight reservation I've got here is when I press this in, down here, I don't know whether you can see that, there's sort of not that much metal there between the hole and the outside edge, and obviously if that isn't airtight then I'll have a leak. In hindsight, if I was to make it again, I'd make it a bit thicker. But anyway, we are where we are. So what I'm going to do is I'm going to put that in the fridge and go and put that in probably the oven, and take them out and see if I can just press them in, and that will go flush with that. That's the plan. Well, the press fit went okay, so now I just need to drill into the cage with this 1/4 inch drill bit. Well, they've turned out pretty good, I think, and the valve seats I've cut to sort of roughly the Jerry Howell specification, which is just around 20 thou, probably a bit bigger than 20 thou, but and how you can machine that valve seat in there, in that position, I've no idea. But anyway, they look good, and that's how they joined together, bolted through. And that's it bolted together, and that's where the fuel mixer will go once I've made it. It looks pretty good, I think. Well, I must say that turned out to be quite fiddly, but I got there in the end, and to be honest, a year ago I wouldn't have even considered modifying the drawing, but I guess with this one I had a little option, because I didn't have a clue how to cut that valve seat inside the body. But in my next video I'll be covering the valves and the springs, and hopefully I'll be able to test the compression somehow. But I hope you enjoyed the video, and I hope to see you later.